All right, so this lesson is Desmos lesson number 3, Quadratics part 2. I'm going to walk you guys through the rest of the information that you need to complete the Desmos assessment. When I went into formative, it looked like a bunch of people had already submitted this, and I had said not to submit it. So whether you were in class or looking at it for the homework, I did have that not to submit it. So I won't go ahead and unsubmit that for students because some of the stuff in there you legitimately haven't been taught how to do until you get through this lesson. So now this lesson is not just going to be how can I do stuff on Desmos that we've been doing in class. I mean, it's partly that, but it's also some new content and new material that we're going to be looking at. So I'm going to go ahead and click preview on this, which should open up the lesson in a preview window, and go ahead and click start so that you are able to see what you should be looking at. Now, I have not tweaked with the point values on this, and I'm not totally sure that I will. We'll see. Okay, so for this, we're going to start off with this. So graph the following quadratic in Desmos and use Desmos to highlight the positive intervals in red and the negative intervals in purple. And so this is new. We've done a lot of increasing and decreasing, and hopefully you have already done those questions in the actual assessment, because if you haven't, it's going to be tricky getting like that content straight with this content. But so we're going to do positive intervals in red and negative intervals in purple. Upload your file or paste a screenshot into the comments. Now, I don't know if it will let me highlight this. This might just turn into gobbledygook, but I'm going to try. So let's click over to Desmos. That looks like fun. Well, that did not work, but I actually think we got enough of it that I can tell what happened there. So that should be x squared is what that 2 is. And then this should be plus, really? Plus 7x plus 6, and it is yelling at me because of that. There we go. Okay, so there we go. I'm going to move that over. Now, positive intervals are where it's above the x-axis, and negative means below the x-axis. So in contrast, decreasing would be this piece here all the way down to the vertex. Okay, and we covered that a lot in the last unit. And then increasing would be this chunk over here. But we're going to be looking at what it means to be positive. Now, here's the thing about positive. It's above the x-axis. So it's positive. Whoop, that was weird. Here, and then it goes negative for a little while, and then it goes positive over here. Okay, now, so what I'm going to do, I'm actually going to start with the negative interval here, because the negative interval is a little bit easier to do. So the way I'm going to highlight that is I am going to say, we're going to use y, because that's where it's negative, is where y is less than 0. Now, here's the problem with that. This is bad because I've highlighted the whole chunk of it. Now, just for contrast, okay, we're going to do y. Wait a minute. Negative was supposed to be in purple. So if you guys remember how to change that, you click on that, you go up to edit list, and I'm going to go ahead and change that to purple. Now, I think that's going to be okay with the purple function. And then we'll have y is greater than 0, and that we want it to be in red. Okay, so we have the right colors there. Now, here's the problem with that. That is good for highlighting positive and negative. So you can clearly see like any part of the function that is in the red section is positive, and any part of the function that's in the purple is negative. But what's not cool about it is that basically you've highlighted everywhere, and that doesn't actually tell us the intervals. So what we know about this is we know that it is positive until it gets to the -6. Then it becomes negative until it comes over here to the -1, and then it becomes positive again. I'm going to trace that again for you so you can see it. Positive, 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 positive. Then it hits the x-axis. Now it's negative, 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 and now it is positive, positive, positive again. Now, I'm going to start with the negative. Now, what we're going to do is we're going to put in some sets. I really hope I remember this. I probably should have practiced it beforehand. And I'm going to type in the interval where it's negative. So it was negative in between the -6 and the -1. So like this stretch of the function right here is where it's negative. So in my set symbol there, which we did look at earlier, it's like the first thing we did this year, we looked at sets and like the squiggly brackets for the set notation. Well, we're going to talk about the set of numbers where -6 is less than x is less than -1. Whoops, I have an extra x in there. Let's get rid of that. Okay, now what I did there was I basically did what's called restricting the domain or restricting the interval. Those of you that did the extra credit on domain and range probably got some practice with that. Okay, so if you did that particular extra credit, this is going to work in your favor. So what I did was I basically said where it needed to be purple. Now the red is a little trickier because I've got two intervals where it is red, and I gotta remember how to do this. So we want it red when x is less than -6, meaning it's going to the left. So I'm gonna go ahead and type that in. Whoops, I need the right set symbols. So we need the squigglies. X is less than -6. So that's good. And then I think we do a comma. And then we want where X is greater than -1, meaning it's going off in this direction. So we do a comma. X is greater than -1. Aha, yeah, I remember how to do it. Okay, oops. Put an extra one of those. Okay, and there you have it. So what we can see now, so we kind of eliminated the chunks that shouldn't be highlighted. So positive, 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 negative, 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 positive, 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 positive. Okay, and when you have done it correctly, it should look like this. And it really does go on for forever. Okay, so if I like zoom way, 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 way out, okay, you can tell it's getting like super skinny. But if I look at my x value here is 35.93. And eventually, like if we pulled this, we did this before. If I come way up here, okay, now my x value is 224. Now, does the parabola get really skinny looking at that point? Yes, but look at my y coordinates. I'm up at like 50, 60,000. Don't really want to be up there, so I'm gonna click my little house and bring me back to my home screen. And what you're gonna do is snip a screenshot. Oh, look at that screenshot. That's fun. And make sure you're getting the graph and the functions over here on the left. So your screenshot should have like the function, it should have your intervals with the colors, and I should see the graph with the highlighting. So all of that should be covered. And I'm going to come back over here. And I am not in the like business of saving all these like screenshots. So I'm going to open up the comments, hit Control V, paste my screenshot, and it is submitted. Yay, done. Now I wanted to make sure that I covered, make that go away, like different scenarios for this. So we have graph the following quadratic. This is exactly the same question. So what I'll probably do in class is after walking everybody through that first one in detail explaining everything. This one I will give students an opportunity to do on their own. So go ahead, pause the video and do this one on your own, and then unpause the video to check to what you did before you go ahead and submit it. All right, I'm going to go over here and I'm going to go paste it in again, even though I know it's not going to work. It's still, yep. All right, x squared plus 2x plus 15, and delete those, and I'm going to zoom out. Okay, so this one is a little bit different because it is flipped over. And if I look at my x-intercepts, I have -3 and 5. Only this time, this is where it is positive. Boom. So I'm going to go ahead and do that first. I just find that the easier one. Positive means y is greater than 0. And I want that to be the case. What did I want? -3 up to 5. So we'll say -3 is less than x is less than 5. Go me. There we go. And I need to change that shading, so that is supposed to be done in red. So there we go. And now I'm going to try to tackle my negative intervals. So I want y is less than 0. That'll make it negative. And oh, it came out purple. Yay. And that's going to be when x is less than 3, because we're going to the left. So x is less than 3. And over here when x is greater than 5. And so I'm going to open up my set symbol. I'm going to say x is less than -3. And the word we would use there is or, not and, because like x can't be less than 3 and also greater than 5, but either or of those. So x is either less than 3 or x is greater than 5. So I'll type in x is greater than 5, and there we have it. So again, double checking what you did. Check your colors. Okay, that's part of it. Is the positive needs to be in red and the negative needs to be in purple. And when you do your screenshot, make sure that you are getting all of that in your screenshot. And I'll come over here and paste it into the comments. There we go. Voila. Beautiful. Okay. And I wanted to make sure we just did both of those, and try to avoid stuff like, well, when it's flipped this way, then this, like, go back to the definitions. Positive means greater than 0. Negative means less than 0. And it would be the y in this case. Now, the next series of questions are all about solving by graphing. Okay, and there's, I think I'm going to do this a couple of different ways. I'm going to write this down. So we have 2x squared equals 5x plus 12. Okay, so I'm going to do this, I think, 3 different ways for you, and you can kind of pick which one of these you want to go with. So the first way you could do this is with 2x squared and just like type in the equation. Okay, and that looks pretty good, and you could do that, and so you can see the solutions are -1.5 and +4. Okay, that way you've done it like plenty of times. Now, another way you could do this is do something like this, where you do y equals 2x squared, so that's the left side, then do y equals the right side, and in this scenario, you are going to look for the points of intersection. And you can see that the x coordinates, because remember we're solving for x, are still -1.5 and x is equal to 4. So that's another way you can do it. Now, a third way you can do it is this. The original equation, I'm just going to type it here so that we have something to look at, was this. Now, what I'm going to do is solve this like basically set it equal to 0. And to do that, I'm going to subtract 5x from both sides, and I'm going to subtract the 12 from both sides. And what that's going to do is give me 2x squared minus 5x minus 12. And that is going to give me a parabola where the x-intercepts are negative 1.5 and 4. And so you can do that pretty much like any of those three ways. So I'm going to go ahead and I'm going to highlight my solutions, and I believe that's required. Okay, and the key thing you want to notice there is that the x-intercepts are the solutions. And we've done several things with like kind of like extra credit or bonus stuff that we could do. Okay, I'm gonna go ahead and paste that in. And you can paste in any of those versions that I showed you. It would be fine. But there's like they all have advantages. And sometimes when you do it one way, you can't see the solutions really well. Like you just can't see them well. And so if you can't see them, you got to zoom way out or something, you zoom way in, or maybe they're not highlighting the way you want. It's nice to have like another way. Okay, so what were the solutions to that? What do we have? Negative 1.5 and 4. Okay, so x is equal to 4, x is equal to negative 1.5. Okay, moving on. That was question 4. Now, this is another one with the graphing. Okay, so we're going to take a look at this one. 2x squared plus 4x equals 4x minus 8. So let's go and check that out. So 2x, oh, get my cursor over there. 2x squared plus 4x equals 4x minus 8. So this is potentially problematic for you, especially if the requirement is for you to post a screenshot showing where the solutions are. And you can see I'm zooming out. I am out to negative, well, I mean, big numbers and small numbers. What do we have? Like 2 million. Okay. And I'm still not seeing any x-intercepts. So you might know what that means. Okay. You might know what that means. Or you might not know what it means. So we're going to explore some of those other ways of looking at it. So I'm going to do this. I'm going to set this equal to y. Okay, so this is where those other ways of looking at it might come in handy. And then we're going to copy that and make that. And then I got to go delete it up here. Whoops. Okay, now this might shed some light on it a little bit more because you're seeing something. So in the last one, we graphed them and then we looked to see where the graphs intersected. And what you can see here is that there is no intersection. Like you can see the graph of the left, like 2x squared plus 4x, you can see it. And then you can see the other side, 4x minus 8. And what you can also see is that they are never equal. In the original problem, okay, if I put the original problem up here, okay, was saying that they were equal. And what you can see when you graph them, you graph the left and you graph the right, and you can see that those are not equal. Those are never equal. They're never the same thing. And so that might lead you to say that there are no solutions. Well, there are no real solutions. So the last way we can look at this is to graph the parabola. And so I'm going to take this and set it equal to 0. So I'll subtract 4x from both sides. Now, if I subtract 4x from here, it goes away. It also happens over here. So the 4x's actually drop out. And then I'm going to add 8 to both sides. So I'm going to have 2x squared plus 8. Okay. And what you see here is that the parabola has no x-intercepts. The x-intercepts, when you set it equal to 0 and then plug in the y and go to graph it, the x-intercepts are your solutions. And so this one has no x-intercepts, this one has no real solution. So for our screenshot, I like this screenshot. I also like the other one I did where you could see both of them and you can see, hey, there's no intersection there, just no intersection. But like this one is okay. So I gotta go over here. Oh, I'm not uploading it. I do not have that much discipline. Okay. And then on question 6, let's see, the solutions to them are no real solutions because there was no intersection. Now we have one more of this type. So we have x squared plus 16 is equal to 8x. So we've got our different ways of doing this. So x squared plus 16 is equal to 8x. And this one, you might like zoom out, zoom out, zoom out. And for all intents and purposes, it looks like that only has one solution at the x is equal to 4. All right. But let's kind of explore that some other ways. So in this one, we have, we can do, oh, sorry. I do that. Be consistent in how I'm doing it. Y equals, and then we're going to go ahead and do y equals the other side. And let's see if we can zoom in and see what's going on there. That's really hard to see. It's showing a point of intersection at x is equal to 4. And if you're wondering, how did I get that? I basically tapped on that, and remember, Desmos will give you like a dot where they intersect. So you can see the purple line down here, and it's getting closer and closer and closer to the green line. Right there is the intersection. But if I come up here, look at where the purple line is. It never crossed like into the parabola at all. It like grazes. If I go down here, it like grazes. It almost looks like it tracks along with the parabola for a while, but it never actually goes in the parabola. It might be easier to see if I zoom out. You can see that the purple line kind of comes up and it gets really, really, really close to the parabola for a while. It intersects it, but then it never crosses to the inside. And I know that because there's not another point of intersection. If it crossed it again, like if it went on the inside and then crossed outside, there would be another point of intersection. Now, here's what I think is the best way to actually visualize that. Okay, remember this was our original equation. I'm going to go ahead and subtract 8x from both sides. So that'll give me x squared plus 16 minus 8x. Get these out of the way. Okay, and what you can see, there's our 4 again. All right, there's our 4. And what you can see there is that it's actually coming down and touching the x-axis, but it's not crossing to the other side. And so this is one that has one real solution because the parabola is just coming down and touching. Now, on your assessment, you are not going to have to go through all of this, but there is going to be a matching question where you demonstrate that you know the significance of the different ways that a graph can show the solutions. Okay, so what's this one? This one is x equals 4. Okay, now questions 9, 10, 11-ish. You want to solve the following using the quadratic formula. Question 9 is identifying your A, your B, and your C. Remember that A, B, and C are numbers, and they do have to be in the right places. So I could have scrambled this up. I did not scramble it up. So they are going to read from left to right. Just remember that they don't always read from left to right if somebody has put them out of order. So A is always the number that goes with the x squared. So this would be 1x squared. My B is the 7 and the C is the 8, okay? And we want to remember that A is equal to 1, B is equal to 7, C is equal to 8. Now, what we're going to do is input for number 10, input the quadratic formula into Desmos and use the sliders to evaluate the formula. Be sure to include both the positive and negative versions of the formula. Upload or paste your evaluation. All right, so what we are going to do is put in the quadratic formula. All right, so here we go. X is equal to, go ahead and put that fraction bar in first, okay? Because it's going to be tricky to put it in if you try to put it in afterwards. And we want the quadratic formula, so that is the opposite of B. Now, here's what the positive and negative means. Desmos does not have a plus or minus button for us. We can write plus or minus, but it can either add for us or it can subtract for us. It cannot do both. So I'm going to go with the plus, and then I'm going to use the square root of b squared minus 4ac, just dumping it in there, all over 2a. And what I'm going to do is highlight that entire thing, Control C to copy, Control V to paste, and then I'm just going to change that plus sign to a minus, because why would I type that whole thing twice when I can copy paste it and just change it? So that's what I meant by the positive and negative versions. Now it's asking us to add sliders. So we are going to go ahead and I'm going to see if I can tweak this. Yeah, I'm going to click them in, or well, where's the C? Wait a minute. Oh, there we go. We wanted all of them. I don't know what happened there. All of them. So what we got going on there is we have now added these sliders, okay? And what these sliders do is they allow us to mess around with the values of A, B, and C. So you can set those A, B, and C's to anything you would like, but we want to use it to evaluate what the formula we just put in, where A is equal to 1, B is equal to 7, and C is equal to 8. So you can mess around with this until you get like A is equal to 1, okay? So you can do that, which is what I just did. I just kind of slid it back and forth. Or what's easier is type it in. Now, be mindful of, oh, you can also like play it where you like make it slide. Just if you want to, we don't want to do that, but anyway, you can also click there and just enter in the value that you want. So B is 7. Now notice this did not go A, B, C for me, and that's because of like the order you type them in. So yeah, all right, and what was C? C is 8. So you can just click there and type them in. Now this is going to be a little bit tricky to screenshot. Ooh. Because it's got too many lines. What do I want you to do? I think this will work okay. All right. I know we're cutting off the bottom number there, but unless I can make the screen smaller. I can do that. Okay. So here's what I want you to do. If you guys don't know what I did, you're going to hit the control key, and then you're going to click the minus sign. Actually, mine was kind of big in the first place, so maybe yours fits. But if you click control and then the minus sign, you can like shrink it down. And what you are going to screenshot for me is this chunk here. You don't really need the graph on this one. Okay, so I can see both the positive and negative version, and I can see your sliders set to A is 1, B is 7, C is 8, and be mindful of the order of those when you are entering them in. So that is what you are going to screenshot. Now, here's the issue. If you were doing that, question 12, chances are your multiple choice question is not going to have decimal answers. And so one of the skills you want to have is the ability to mix and match the answers. Okay. Now, we also want to be smart about how we like do this. So if you look at this now, yours, I probably have it set to scramble. Okay. The answer choices. So yours might not be in the same order as mine, but notice that it has one of these has an I. If I come over here, I don't have an I in these answers. Okay. So I can eliminate that right off the bat. Okay, I'm not going to pick the I. The other one I can eliminate is this one that has a 2x. We never, ever, ever, ever have an x in our quadratic formula. Okay, like those are only numbers that we throw in there. We only end up with numbers. So not that one. So that means I'm left with these two. Okay, so what I need to do, they both have the square root of 17. They both have the 2. The thing that's different is the 7 versus the -7. So I need to just plug one of those in. I don't need to plug both of them in. So I'm going to plug in 7 plus the square root of 17 all over 2. So I guess I'm going to come down here. All right, so putting in my fraction bar, and we're going to do 7 plus the square root of 17 all over 2, and I get positive 5.5, blah, 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 blah. Okay, so positive that. That's not one of my answer choices. Okay, that's not one of them. Therefore, that's not my answer. Okay, that's just not it. I've ruled that one out. If it did match, what I would do is I would quickly sub out that plus for a minus and just quickly make sure that the other one matched, just to make sure I didn't have some weird situation where like I had one matching, but I mean, that would be very rare. Notice that this one has a positive 1.43 when I need a negative. Kind of gives you an idea of what those numbers do. But that answer choice was not the correct one. So the one with the positive 7 was not correct. So I can go with the one with the -7. I can feel pretty confident about that. If I want to make sure, I can just like make that a -7 and just double check. Yep, now the negatives match. Okay, and I can go and change my plus sign, and up now those match as well. And so now I feel pretty confident. I actually feel very confident that I have matched them up. So that's one way that you can get around the fact that Desmos is going to throw decimals at you, and you might have answer choices that are not decimals. Now, for the last question, I want you to ask me what would happen if, based on this lesson. That's going to take you a little bit of time to think of one. If you just say, I can't think of one, I am taking off the points for this question. This is challenging, okay? What would happen if? And I'm not even going to give you some hints, okay? But look at what we've done in here, okay? What would happen if? Okay, maybe mess with the A's, the B's, and C's. What would happen if you messed up the A, the B, and the C? You know, how would that work? What would happen if, think about these questions, equations that we solved, you know, they don't even have to be questions about quadratics. Go back and ask me something about lines. What would happen if this were a line or if this were something else? Okay. Positive and negative intervals. What would happen if? So take your time to think of a question for what would happen if. And that should set you guys up to finish that quadratics Desmos assessment. I'm going to go ahead and say that that is going to be due. I don't have a calendar in front of me, but this coming Friday is the 31st, and I'm thinking the Friday after. So that would be the 7th, I think. So the 7th, at least the year that I'm recording this. If it's not the 25-26 school year, I will obviously let you know when I want this to be due. All right, as always, you guys know where to find me, and I'll see you in the next one.